We're going to take a look at the RAVPower wireless charging system that uses inductive charging that's compatible with Samsung and Apple's smartphones. We're going to take this thing apart, take a look at it, and we're going to actually do a fast charge and see how well it performs. Let's take a look. I've got here the RAVPower wireless charging pad that can be used on iPhones and Samsung S8 and the likes, phones that have got wireless charging abilities. Let's check this out. What I'm going to do is I'm going to charge a Samsung Galaxy 8 phone using the wireless charger. In the package it comes with the charging cable and the wireless charging pad. I'm just going to connect this to my existing, I'm only using a 5 volt 2 amp charger, so I'm not going to get the super fast charge out of this. We're going to power it up. We have a little light that comes on here to indicate that it's got power, and this is how simple it is to charge your phone. Just take your phone and you just set it on top of it here and it should light up. So as you can see, the light lights up green. The phone is now charging. We're going to let it sit on the mat here and we're going to see how long this thing takes to charge. So the screen won't stay on while I'm charging this, but as you can see, we are starting at about 58% right now. This is my daughter's phone, so I can't unlock it or anything, but yeah, we can see, what's it say here? Charging wirelessly. The message that comes up on the bottom of the screen here, and it says that we are, in fact, charging wirelessly, and we'll let this thing charge. It says it's going to take about an hour to fully charge this phone. I'm going to leave this thing run here, and we'll check back on this thing and see how the charging is taking place. I've got the 9 volt factory charger. We're going to plug that one in and see how much faster it will charge on 9 volts, because this will charge on either 5 or 9 volts. I'm going to use the cable that came with the RAVPower charging mat, because as you can see, as it sits on the 5 volt charger, it's going to take about an hour and 20 minutes to fully charge. So we're going to plug the other charger in and see how much faster it charges. Okay. I have the fast charger now plugged in. We'll drop the phone on top here. The light turns green and it now tells me that fast charging is now enabled, and we're at 61%. It's 2240 hours now, and we'll see how quick this thing fully charges here. Now it says 1 hour and 7 minutes, so it's considerably faster. We're going to time this and time lapse it to a full charge. And I'll just leave the clock in the background so you guys can see how quick this thing will charge. So here we are. We're at 61% at 2240. Okay, we're at 99% now. It says there's 4 minutes remaining. Getting pretty close to being fully charged. I guess it's fully charged now. It's not giving me any time remaining to charge. So it must be pretty darn close to saying 100%. But we'll call it fully charged. It says it's at 99%, so I think we'll call this phone fully charged at this point. So I'm going to end this charging cycle now, because I think that that's going to be fully charged. The phone is slightly warm. As you can see, it's in a fairly heavy-duty case here, and it's charging through the case. So next what we'll do is we're going to take this apart and see what this is made of inside. See how the quality is, and just show you what's inside one of these charging pads. So let's take this unit apart and just see what exactly is inside one of these charging units. There's going to be some screws, I think, on the bottom of this thing here. Yeah, there are some screws down here, so let's just remove the screws. There's probably some more around the side here somewhere. Well, you know, I got it exactly where the screw is. So there's probably another one, I'm thinking probably over about here. So let's take a look over here. Yep. Okay, so now I should be able to take this thing apart, I think. Okay, here's the inside of the unit. Get a close up here of the actual circuit board. As close as I can get in anyway without the camera going out of focus. So here we have our power input. It's a couple control chips here. And then we're going to have our RF generation. How these work is they generate a high frequency signal, which is then passed on to an induction coil here, which is going to be on the top side if I pop this apart. And here's our induction coil. And basically what they do is they just apply a AC signal, and generally they would run it at a higher frequency than 60 hertz, because 60 hertz is not very efficient. So how these work is they generate from the DC power coming in, and this will accept either the standard 5 volts from a charger, or it will accept a 9 volt charger. The fast chargers output 9 volts as opposed to 5 volts, so you get a higher charging voltage and a higher charging current. The circuitry here generates an AC signal, and it's driven through to the induction coil here. Now the induction coil here, it works like a transformer, half of a transformer. So you've got your primary winding, and on the other side in the phone itself there's another comparable coil that becomes your secondary winding. And this is going to have this is probably a magnetic material here. I'm thinking this base here is going to be a type of a magnetic material. Let's see if I can find something that's magnetic that we can put on there, but I'm sure that it probably is. And I say that because it has to be something that can conduct magnetism to form a transformer. So here I have my magnet that I use. This is all my old parts are in here. And this is actually for magnetizing screwdrivers. You take a screwdriver and you move your screwdriver like that, and your screwdriver will now pick up screws. So this is a relatively powerful little magnet. And let's just see if I bring this near here whether it will pick it up. Aha, you see? This is magnetic. So we know, of course, it has to be a magnet because that's how transformers work. So here's one half of your transformer. You've got your coil here, which generates a magnetic field, which your AC signal is applied to here, and for efficiency, it is going to be a higher frequency than 60 hertz. How high the frequency? Well, the only way I could tell that would be to actually put it into service with it apart. But we probably can measure to see if there's anything on the scope. So let's plug it in and see whether I can pick up a signal on the scope here. So I'm going to put a test stake on here. And I'm just going to do that by melting some solder and sticking it down and letting the solder stick to the unit here as a couple of test stakes. Therefore I can connect my scope up to it, ground to one side, and the scope probe to the other. I'm going to use the digital scope for this over the analog scope, just because it has a built-in frequency counter and we can look at the waveform that this is generating. So when I plug it in, it should initialize and give me something on the scope. which it does. Let's take a look. So if we look at the scope, here it's in power sensing mode because we're not put up against a phone, therefore it's not going to be operating. So it's turning on and off quickly to look for a compatible device on the other side, something that it can induce a signal with. I'm sure if I were to put a coil of wire on the other side here, I could probably make this thing actually start up too. Okay, so I'm set for my times 10 probe. I click measure, and I'm going to just capture this. So let's look for my trigger menu. That's what I'm looking for. Trigger menu. We're going to take a single capture, and we'll run it, and it grabs me the waveform. So that's the beauty of a storage scope, is when you have an event like this, you can capture it. Whereas an analog scope, you can't. The old analog scope that's above this one, the Tektronix, is better for looking at analog waveforms such as video waveforms, and for working on VCRs and adjusting the gain on CD players and so forth. But when you're dealing with looking at fast waveforms like this, you can't beat the digital scope. So now we can actually look at this and we can analyze this, and we can see that it's 24.17 kilohertz is the frequency that this operates on. And if I want to measure the if I turn my cursor on, we can see this is into an open circuit. This is not an inductive load. This would, I think you'd see that this would be much less if I had the phone here, which I don't. I don't have the phone to couple to this so that I can actually see it under load. So we're just looking at this under no load itself. But 39 volts is the inductive load into that primary side of that wireless transformer, or wireless coupled transformer. So that's interesting. 24.1747 kilohertz is the frequency this thing operates on. And the reason this waveform is really looking like this is, well, how this is working is you've got a couple MOSFETs that are turning on and off, and they're not forming a full sine wave. They're turning on a partial waveform because this is going to be pulse width modulation, and this would actually vary when it's coupled to a phone to compensate for the actual load itself. If I were to put this to a phone and measure it, we would see probably a much cleaner waveform than we're seeing here. Anyway, I don't have the phone to charge it with now. I had to borrow the phone to charge this because, well, my phone that I have a BlackBerry Priv, and it had advertised wireless charging, except for I bought mine directly from BlackBerry themselves. And like the phones sold on the international market and the phones sold in the States, they all had wireless charging. But the Canadian carriers got cheap and ordered them without the wireless charging capability so that they could get a discount on the phones. And unfortunately, my phone, the original one that I had, packed it in, and I had it replaced under warranty. The replacement one they sent me was, guess what? A Canadian carrier version that does not have the wireless charging. So I've got this nice wireless charger that I can't use, but I borrowed my daughter's phone, and that's the video you saw when we time-lapse it to show how long the thing charges. It actually charges up really quick. Back looking at the unit again, you'll notice that it does have a temperature sensor here that is actually pressed up against the top cover. That way, if the phone were to overheat, or this transformer were to overheat, it would shut the unit down to prevent it from becoming a hazard. So that's about it. I'm going to put the unit back together now, and we'll get it all set for when I do finally get myself a phone that I can take advantage of the wireless charging technology. This unit looks to be a really well-built unit, and I have no faults that I can find with the construction of this thing. It looks to be first-rate. Links to this device is in the description, and thanks for watching, and as always, we'll catch you in the next one. Bye for now.